Continuation for preparation of salts MCQ question paper. Question number 7. Which method produces the salt copper 2 carbonate? So what do we have to do to create a copper 2 carbonate? So as we recall, copper 2 carbonate is one of our insoluble salt. Therefore, one way of preparing it is through precipitation. So just recap the main difference between precipitation and neutralization. So when we do precipitation, we combine two soluble compound. So we make it into an aqueous solution. And when we mix the two aqueous solution, they form an insoluble salt. Then that insoluble salt is mixed with another liquid or another solution, another compound that is soluble. So how can we separate the insoluble salt? We just need to filter it. On the other hand, when we are doing neutralization, we usually require one aqueous solution. Mostly it's acid. Then we add an insoluble compound. It can be an insoluble base, insoluble salt, insoluble acid, insoluble metal, or carbonates. But the resulting product, once we filter the excess, the filtrate, we crystallize it and dry it, it will form crystals that is soluble. Okay, so in this case, we are doing precipitation. So our target is to find the two aqueous solution. So we already know that the aqueous solution for that will be our acid. So let's check our choices. Letter A, add copper 2 oxide to water. So we have to remember that our copper 2 oxide is insoluble in water. So you cannot form a solution by adding it into water. Then add excess aqueous sodium carbonate. That is actually possible. Filter off the precipitate. So that makes our option B the correct answer because it says here to add the copper 2 oxide to dilute sulfuric acid. So now it will create an aqueous solution. Then you will add that aqueous solution to our aqueous sodium carbonate. So when you have sulfuric copper oxide and sodium carbonate, then you will be able to create a copper carbonate. So you will filter off the precipitate. Letter C, you add copper to dilute hydrochloric acid. This is also not possible because copper is less reactive. So it will not be able to react with our hydrochloric acid. Letter D, add copper 2 oxide to excess aqueous sodium carbonate. So in this case, as we have mentioned, our copper 2 oxide is only soluble in acid. So we have to dissolve it first. Okay, so that gives us the answer for number 7, which is letter B. Next, number 8. Copper 2 sulfate is formed by reacting excess copper 2 carbonate with dilute sulfuric acid. So again, as we have mentioned, copper 2 sulfate is soluble, while solid copper carbonate is insoluble. Therefore, we are creating salt, a soluble salt, if we use insoluble compound in acid. So it means we are doing neutralization. So we are using insoluble copper carbonate mixed with sulfuric acid. Our equation will be copper carbonate plus H2SO4. So this is the insoluble one. This is our aqueous solution. It will form a copper sulfate which is soluble, and CO2 and H2. Question here is, which process are part of the preparation of solid copper 2 sulfate? So what are the steps in this? So again, we have to add excess copper carbonate to our dilute sulfuric acid. We warm it after we dissolve, and when we already have excess, when it's not dissolving anymore, then we will start to filter. So it's the first step that we have to do, to filter it. After we filter it, the filtrate will be evaporated. We're going to evaporate. Then when we evaporate it, we will leave it to dry so that it will form crystals. So the part crystallization and filtration are the one included in our preparation. Distillation is not needed because it involves condensation, which we don't require. Titration also is not needed because titration is only used when we have two soluble compound. Again, the neutralization between the acid and the base. So the answer here is 1 and 3. That will be letter A. Question number 9. So we have here a net ionic equation, and we are asked to find what type of reaction is represented by this. So when we form a net ionic equation, it means that we have aqueous solution. So this is our lead nitrate. Then this is another aqueous solution, which is sodium iodide. Then it reacted and formed a solid, which is lead iodide. Then another aqueous solution of sodium nitrate. So from here, you already know that we have two aqueous solution and we form one solid. So this solid is our precipitate or our insoluble salt. So we can say that we follow precipitation method. Number 10. Information about silver compounds is shown in the table. Which equation shows reaction which cannot be used to make silver salt? So which one is not possible to happen? So we are given here the list if they are insoluble or soluble. So let's identify one by one. We all know that our aqueous solutions are all soluble. So just identify the silver. Silver nitrate is soluble. Silver oxide is insoluble. That's why it's solid. Silver carbonate is also insoluble. So you see it has a solid sign. And silver is solid as well. Next, we need to see, based on their, if soluble or insoluble, what kind of reaction we are doing. So letter A, since we have soluble and soluble, and it creates a sodium chloride, a silver chloride, which is insoluble. Therefore, it means we created using precipitation. Next, we have insoluble silver oxide that forms a soluble silver nitrate. Therefore, this is neutralization. Letter C, we have insoluble silver carbonate that forms silver nitrate, which is also soluble. Again, we use neutralization. Okay, now let's take a look at letter D. It says here that the silver reacts with hydrochloric acid. This is actually not possible to happen because, as we all know, silver is less reactive than hydrogen. Therefore, it will not be able to replace hydrogen and hydrogen chloride to form a silver chloride. So that's not going to happen. So now that answers our question, which one cannot be used to form a silver salt. Number 11, aqueous ethanoic acid is a weak acid. Aqueous sodium hydroxide is a strong base. Okay, so let's recall the idea of weak and strong acid, weak and strong base. So one of the key words that we have to remember when we're talking about strong, it means they can fully dissociate. So when we place a strong acid in the water, they will fully dissociate. However, when we place a weak acid in water, they will partially dissociate. Another thing that we have to remember when it comes to strong acid and base is their pH. Okay, so the pH for strong base is ranging from pH 12 to 14. Therefore, 8 to 11 is actually weak base. Aqueous ethanoic acid is neutralized by aqueous sodium hydroxide. So whether they are weak or strong, as long as they are acid and base, they will be able to neutralize each other. Okay, so those are our basic statements. Which statements are correct? Number 1, aqueous ethanoic acid accepts proton from hydroxide ions. That is actually wrong because, as we all know, acids are donor. They are proton donor. And the one that accepts are the base. Statement number 2, the aqueous ethanoic acid is used to fully dissociate into ions. So as we have mentioned, ethanoic acid is a weak acid, so it will not be able to fully dissociate. Instead, it can only partially dissociate. So when we draw it, we always put the two-headed arrow to show that the ions are not fully dissociated. Number 3, the aqueous sodium hydroxide is used to fully dissociate ions. Yes, because as we mentioned, sodium hydroxide is a strong base, therefore it can fully dissociate. Number 4, the product produces salt and water. So when ethanoic acid neutralizes, they will form both salt and water. So the correct statements are number 3 and number 4. The last one, we have to identify which row shows the state symbols for this equation. So one way to help us is to check whether they're soluble or not, so that we can know if we will be able to place them in aqueous solution. So remember, the acids are placed in aqueous solution, and we put AQ for H2SO4 and HCl. On the other hand, barium chloride is a soluble compound. It's a chloride. Therefore, we can also put it in AQ. Barium sulfate is insoluble. Therefore, we put S on it. So the correct answer is letter A.